Okay, so thank you for inviting me to this special session on the inheritance in rifting processes. So I will be happy to discuss about the control of Mesozoic orogen on the marginal basin of Southeast Asia. This is a case example, knowing that all the orogens run parallel to each other, they need to be reactivated. So I will sort of look at it from the moon on a very regional scale, try to bring some consideration. So I will use in this area a margin that have been thickened by tectonic thickening, but also with the involvement of magnetic arc, and then discuss when the external forces change. We have an orogenic collapse, and I will discuss whether there is a shift. How is the shift between this collapse and the rifting, subsequent rifting? So considering all the orogens which are parallel, this is the Variscan orogen. You see that beside the Ural that separates the Baltic and the Siberian belt, all the belts will run parallel. This was Eocene, this is Indocene, let's say Triassic, Jurassic deformation. Then all the Tethys, Neo-Tethys linked orogens. Then the formation of the Alps, and finally the present deformation. So we know that all these orogens run parallel to each other. This must be because the crust is easily affected. Basically, the crust is weak because it's radiogenic and because it is also very thick. But you also see that the crust also involves lots of large faults, and also geochemical or petrological differences. There are many granites or intrusive bodies which will be easily reactivated. So I will see whether this has any implication on the rifting. So you won't be surprised that I'm going to use Southeast Asia for this. And in this map of Southeast Asia, you see that there are many structures inside the craton. It's a plate actually. And we have the Triassic. I hope it's not too thin for you to see. This is the Triassic suture. This is also Triassic Bentong Raub suture that runs from Malaysia to through Indonesia up to southern Borneo. And there is also a Cretaceous suture that runs from the Three Rivers area in China and Myanmar, that runs through Thailand and Indonesia, and then goes to Borneo, finally reach the south of the South China Sea part. And we will consider that on this plate, there were several granitic pluton from Permian to Jurassic, but mostly the Cretaceous ones are going to be very useful because they will give us a reference for the deformation. So you see that this very large igneous body is all around the Sunda plates. And of course, we can measure, we can look at the stress in this craton and see how the basins developed during the Paleogene and the Neogene afterwards. So to look at specifically near the South China Sea, you see that those brown patches here are the craton, the plutons, actually from lower Cretaceous up to middle Cretaceous. The last one here is dated 120 million years. And we can reconstruct the South China Sea and identify east of this boundary of the craton, this one actually, you can identify a former Cretaceous orogen, which was called the Yanchanian orogen, that has later collapsed. It is very difficult to see when we shifted from an orogenic collapse to a proper rifting. The orogenic collapse is indicated by early basins with a molasse inside, and the rifting is dated late Cretaceous, and the rifting started basically during the late Paleocene and the early Eocene. So let's go back to this belt of plutonic belt. You see that all around it, we can, for example, see the conjugate set of joints, which are here in Thailand and also Myanmar as well, which are here in Malaysia. They indicate an east-west compression in those Cretaceous granites. And then in the very south, in the Schwaner Mountains in Borneo, they are north-south. And if you go back to Vietnam or to southern China, we again have an east-west compression. So you can do this statistically on the DTM. We also looked at all of these in the field, of course. And when the crust was stretched later, you see lots of different morphostructures. Basically, there are some under the shell. This is Hainan Island. This is the South China Sea here with this diachronous opening that we all know. And you see that some of those features, they're round, ovoid, like this one, like this one, this one. So they're all indicated here. Hainan is one of them. And they are basically composed either of metamorphic or granite. For example, this is the granite that was mentioning just near to the continent-ocean boundary. It's Cretaceous granite. But also during the IODP in front of the Pearl River mouth, there were also metamorphic rocks that were drilled. We can see that also on the seismic refraction that we did using OBS, and we observed all the basins and these pieces of crustal budinage. And when you look at the seismic reflection this time, you see that the edges of the granite have been reactivated by these low-angle normal faults. This was a paper from Sava. And you also see that it has been shown that inside the basement, many of the extensional fault, the normal fault, were actually reactivating former thrust. So this was a paper from Ye. And interestingly, on the opposite side, to the west of the Sunda place, it was shown by Morley that we also had duplexes of Cretaceous age that were reactivated during the extension. So we definitely reactivate some of the structures. It's possible also, I like this cartoon from Deng and others, where we see the detachment affecting the crust and also the intrusive bodies. But in some places, we may have also a little bit of lower or middle crust cropping out in those domes. If we go to the continental part, this is in front of, this is the Pearl River Delta, Hong Kong is here, Shenzhen would be here, and Guangzhou would be there. You see that the Cretaceous faults, all here, are reactivated by large detachments in which you will find these early molasse, probably latest Cretaceous or Paleocene. And if you want to do a section in this, we always draw sections which are similar to this seismic line on which you see the Cretaceous fold, a large detachment fold cutting the short limb of the fold, and then all the syn rift and post rift sequences. The sediment will be deposited in this area. When we discuss about, and this is probably the most interesting, when we discuss about the divergency of the fault, we see that most of the faults are counter-regional. So there are several sections that I took here in front of the Pearl River, but also many others described by Franke and others. We see that all the faults are verging towards the continent. If we go to the opposite side, to the western side of Sunda, same thing. We will see along the Malacca Shelf here and the Mergui Ridge, again, only a counter-regional normal faults. So that raises some questions, because when we pass this boundary of thick crust, which is affected by this continent verging fault, we reach an area with very a thin crust. This is in the Andaman Sea here, where the crust becomes very thin. And then this time we obtain proper rifting fault, which are the distal normal faults. But interestingly, if we go along a north-south section, we will see that the extension is even more intense and shows that it's a north-south extension. So basically what we are thinking is that when the crust is thick, this is all along this Thailand, Malaysia peninsula, we do reactivate the crust with mostly counter-regional normal faults. And when we suddenly reach a very thin crust, then the regime changes completely and follows the present geodynamic setting. It is just like if we're having a sort of, if we loses the memory, if the thin crust loses the memory of its initial configuration. So thinking about that, we said, okay, probably along the Sunda, the whole of the Sunda block, we having in the middle these Triassic suture, which are verging towards the continent, of course. Then we have on both sides this Cretaceous set of suture zones with all the faults associated with it. And when you stretch the crust, you do reactivate these faults, are counter-regional normal fault, mostly under the shelf. And finally, when the crust is very much stretched, you reach distal normal faults, which are classical for the opening of basins. On a simple cartoon, that would be here the thrust of the early orogen. In the case of Southeast Asia, that would be the Cretaceous orogen, reactivated as counter-regional normal faults, continent verging faults. And then on the opposite side of the granite, we basically have the distal normal fault system. So actually, what we see is that there was a sort of collapse of the magmatic arc, which was deformed. Probably it was also, maybe it's also because it was thick on this location. And in some places, we have thick sedimentary deposits like deltas that also create an overload of the crust. And maybe this would condition the development of counter-regional normal fault, because this is what we observe, for example, in large delta, like in the Brunei deltas in Borneo, in northwest Borneo, where we see that counter-regional normal faults develop in deltas as the loading of the sediment is acting. So possibly this goes also in the debate on whether the vergency of the fault depends only on the hot or cold margin types. Maybe we have underestimated the reactivation of the basement. So in order to wrap up, when we have thick crust, we sort of have difficulties deciding when is the shift from collapse to rifting. Inherited structures are important, mostly around magmatic bodies, but also fault and faults. And they go according to the orientation of the previous orogen. However, when the crust becomes very thin, it sort of loses the memory of the inherited structures and follows the active geodynamic setting. So thank you very much for your attention. I'm ready to try to answer questions and also learn from your comments.
Thank you, Manuel. That was a really amazing overview and adds so much more complexity. Are there any questions in the chat? I don't see any just now, or you can put your hand up in the participants list and I will see that as well. Is there any hope in terms of this complexities of finding these old collapse structures versus this hot margin versus cold margin, flipping of the fault orientations? Is there any hope in dating these things to get a clearer picture of which scenario you might be looking at?
That's the issue, is that in the continental crust, we have complex system, we have several orogens. This is why I decided to show only the last one, which is represented by the Cretaceous bodies. If we go to the earlier structures, it becomes really difficult. But it's clear that we have something concerning the last orogen.
Excellent. Gianretto, you have a question? Do you want to unmute and ask?
Yeah, thank you, Manuel. It was very interesting. You talk about the loss of the memory. Do you have an idea how that this works, or what is the process that makes that the crust can lose its inheritance?
I think it depends on how the faults are rooted. When the crust is very thick, it cuts through a thick upper crust and goes into the lower or intermediate crust. So we have big structures. When the crust is very thin, it becomes a small percentage of the total thickness, so that the configuration of the downgoing plate, for example, in the case of the Andaman Sea, is very important, and it's more important than the structure of the crust of the upper plate.
Thank you very much.
There's also another question from Sasha in the chat. Do you want to unmute?
Yeah, thanks for the talk. I'd have a question on this relative strength contrast between the plutons and the thrust faults. So at the onset of rifting, when we had these cold plutons there, how do they relate to each other? Are there sometimes thrust faults on top of plutons that start to get reactivated, but that are shielded by the plutons? Are all the thrust faults between plutons, or do they also cut through the plutons sometimes? Can you comment?
Actually, what we have seen in the field all around Sunda plate, but also what we see on the images, is that the thrusts do not cut through the through the pluton. They always reactivate either the top of the plutons or sometimes the base. That we see what we see in Thailand, for example.
Okay, thanks.
Are there any other questions? I suppose relating back to Sasha's question, I mean, these plutons, these late orogenic plutons are quite ubiquitous. Do you see similar behaviors to what you're seeing in the South China or Southeast Asia part in other parts of the world where the thrust fronts kind of skirt around the plutons?
We do see that more or less everywhere. Actually, when you look at the contact with the plutons, you always see that they are really reactivated with those kind of stockwerk and fluid circulation. Lots of huge porphyry dike along the plutons, which are actually cataclysite usually. So the edges of the pluton definitely move, but the plutons are not so much deformed. Thrusting during the extension, they may be cut by normal faults.